Hi, I'm Dennis Nagel of Cadence Design Systems. Welcome to Sigrity Tech Tips. Today we bring you another installment of how to sign off on your power delivery network design. Using Sigrity Power Integrity technology, PI problems such as insufficient power, unstable power, and inefficient power delivery can be identified and resolved before you go to the lab with your design prototypes. Our video today will show you how your design team can efficiently address power integrity issues early and throughout the PCB design cycle. Design teams following our suggested methodology can avoid wasting days or even weeks in delays due to multiple design iterations with overburdened power integrity engineers who face analysis overload between new designs to review in addition to designs that have been reworked one or more times to address PI issues. By empowering the PCB designer to work independently on basic PI problems, you can eliminate this process bottleneck. Your PCB designer can be the key in preventing your design teams from having to face PI problems when project deadlines are looming at the end of the design cycle. And because your PCB designers will have access to the same Sigrity power integrity engines used by your PI experts, they can share the same models and setup information. The PCB designer can now play a critical role in the PDN sign-off methodology. By empowering the layout specialist to resolve first-order power integrity problems such as too much voltage drop or excessive decoupling capacitor loop inductance, power integrity experts will be freed up to focus on the difficult optimization and cost reduction tasks associated with competitive product creation. In today's video, you will see us utilize the Allegro Sigrity PI Base. To learn more about this product, visit us at www.cadence.com. Now I will turn it over to my colleague, John Carney.
Hello, my name is John Carney, and I'm going to demonstrate the features of the Allegro Sigrity PI Base. The first feature is the ability to enable a PCB designer to do intelligent decoupling capacitor placement. Instead of just getting a net list with a couple hundred capacitors and no idea how to place them or what main IC they go with, this new functionality gives the PCB designer explicit lists of capacitors that are assigned to each IC in each specific power rail. And then now they know which particular device and which capacitors need to be placed by that particular IC. They are also given visual guidance in terms of the setback distance for capacitors that need to be placed on the same layer, opposite layer, and underneath, also which are indicated here in the options panel. Finally, they are given a visual circle showing the effective radius of that decoupling capacitor, which is calculated by the capacitor's value in the stack up of the board. So this gives the PCB designer, takes a lot of the guesswork out of their decoupling capacitor placement. This information is determined by a power integrity expert at the organization by using the power feasibility editor. The power feasibility editor is a wizard that walks a designer through defining the power and ground nets for a particular design, specifying a target impedance for a particular IC component, and then specifying some capacitor models to be used. And then now the PI expert can experiment with placing these capacitor models on the same layer, opposite model, and underneath the IC to determine if that is going to affect the impedance at the operating range of the IC. The final effect of this is a decoupling capacitor constraint set, which then gets applied to the component inside of the constraint manager. Historically, we've always had constraints for nets. Now we have constraints for components. So now in the electrical workbook, there's a decoupling capacitor template that has this rule assigned to it. And if we look in that rule template, you can see it's assigned to this particular component, and it specifies which capacitors and which pack type need to be assigned on the same opposite and underneath the component. For this second half of the demo, I'm going to show how the Allegro Sigrity PI Base can enable a PCB designer to do work in progress PI analysis. We're going to be focusing on this 1.5 power rail, which comes in through the VRM on this top layer here, and then it goes through a couple of vias, and it has to provide power to these two large ASICs in this memory device here. Right now there are only 3 vias connecting the top layer to this internal power layer. It's kind of an over-exaggerated bad design, but the purpose is to show how the tools function. So a PCB designer, if they want to analyze or design at any point in time, they can go to the Analyze menu and choose DC Analysis interactive mode. What this allows them to do is it allows them to point to an existing workspace file, and this is the power integrity analysis setup done by the PI expert at the company. This can become pretty detailed, involving setting up all the voltage regulator modules, setting up all the sinks in the design, any discrete currents, and which power and ground nets need to be analyzed. If the PCB designer wants to do that, they're more than able to do that, but if they have somebody in their organization that can set that information up for them, then they can just reuse that. Then all they need to do is hit the OK button. In a few moments, the Allegro board file is then presented inside of the Sigrity environment, and since all the setup was already done, all the PCB designer has to do is locate the simulation button and choose to start the simulation. Once the simulation has complete, the tools are put into a cross-probing mode, so the Allegro designer can stay inside of Allegro, zooming and panning around while viewing the results inside of the Sigrity analysis tool. Right now I have the two tools side by side, but if you're a typical PCB designer, you're able to put these things on different monitors. So here the PCB designer can see that the voltage coming into this particular layer goes from about 1.27 up to about 1.46. Zooming all the way out, you can see that these memory devices over here on the 1.5 volt rail are only getting about 1.25 volts, and over here they're getting about 1.29 volts. Well below the acceptable margin. We can also look at plane current density to see how much current is flowing through plane layers. And we can also look at via current. Here the PCB designer can see that the range of current going through the vias in the design goes from about 0 amps all the way up to about 9 amps. And they can choose to show the hot spots to zoom in on the via that has the highest amount of current flowing through it in the design. So having a single via with about 9 amps of current going through the design is clearly going to be a problem. So that needs to be addressed. That same information could be presented to the PCB designer in terms of DRC markers. So if the PCB designer wanted to stay completely in their environment, they can go under the Analyze menu, choose DC violation markers, and then they can look at the same analysis results. And then here they can look at global via current violations, and they can browse and navigate those things through the design to see where in the design they have violations based upon DC analysis. And those things can be marked as external DRC markers in the design. All of this information can be back annotated into the Allegro design as external DRC markers, so the PCB designer can gain insight into the DC analysis results without ever having to leave the Allegro platform. So now that the PCB designer knows that there are some violations going on in this design, they can get to work on fixing the design. So to do that, we'll just copy some of these vias. And we'll do an array of these vias. Now the PCB designer can return to the Sigrity analysis tool. They can just select the net that they modified and choose to update the selected net. After the net has been updated, the PCB designer simply needs to rerun the simulation, and now they can review the results again to see what sort of improvements have been made to the situation. Shown here, the voltage distribution on this plane layer once again shows that for the 1.5 volt net, the scale of voltage over here by these memory devices has now gone up to about 1.32 volts, and this large ASIC down here is once again getting about 1.32 volts. Still not perfect, but it's an improvement over the previous situation. Looking at the via currents, the scale of current going through the vias in the design now goes from 0 amps up to only 2.5 amps. Previously that was at about 9 amps of current through the via. Zooming in, the PCB designer can now see that the via with the most amount of current going through it has only about 2.5 amps. Again, not an ideal situation, but it's a great improvement. So this has shown how a PCB designer using the PI Base functionality can do work-in-progress analysis of the power distribution system. Another option with the Allegro Sigrity PI Base is the ability for the PCB designer to review analysis results while staying 100% inside of Allegro. Under the Analyze menu, the PCB designer can choose DC Report, and then they can look at a report containing only the violations or a full report. This report is an HTML report generated by running DC analysis by the expert in the organization using Sigrity PowerDC. So this is a full comprehensive HTML report listing the stack up, the VRM source sink setup in the design, and then voltage and current distribution plots for every layer, for every net being analyzed in the design. So the PCB designer can use these plots to look at and locate errors in the design, or they can go to the bottom of the report, and then once again in the bottom of the report are the same DC DRC violations that have been set up by the power integrity expert. This enables full cross-probing between the report and the board file. So again, the PCB designer can utilize the errors found by DC analysis using PowerDC and then look at those things and correct them while staying completely inside of Allegro.
Thank you for watching another edition of Sigrity Tech Tips. For information on products used in today's video, click on the links below or contact your local Cadence sales representative or Cadence channel partner.